In this video, we're going to introduce the concept of predictive modeling. We all know that engineering systems can become extremely complicated, but we can always model something about them. There are certain things that we know. Maybe we can write down equations, maybe we can say certain things about some quantities. There's always some known things about the system. We're going to call these the known knowns, the variables that we know that we know. But there are other things that are unknown to us. For example, our model may have some parameters. We may need the acceleration on the moon, the acceleration of gravity, for example, at the moon surface. This is something that we have not measured, let's say, yet, but we know that it is needed in our equations in order to figure out how to, let's say, land a vehicle on the moon. You need to know the acceleration of gravity on the surface of the moon. So even though you haven't measured it yet, you know of its existence, so you say that it is something that you know that you don't know. But there are other things that are unknown, and we don't know that we don't know them. These are unanticipated things about the system of interest, about the thing that you're studying. Things that can go wrong that you haven't taken into account. Now, predictive modeling focuses only on known knowns and known unknowns. And it is in particular the process of describing our state of knowledge about known unknowns so that we can make informed decisions. So it's basically a process that allows you to enumerate all the things that you know that you don't know and quantify mathematically your uncertainty about these things and estimate the effects of this uncertainty on other derived quantities of interest, and then use the results of this analysis to make informed decisions. But what about unknown unknowns? Well, we're out of luck because there's no widely accepted way for turning unknown unknowns into known unknowns. The best thing that I can come up with is basically science itself. So science is turning unknown unknowns into known unknowns all the time. You build something, you test it in various ways, and then all of a sudden you are surprised. You see something that you didn't expect, and you try to figure out what went wrong. And if you look closely into the process of trying to figure out what happened in an unanticipated event, it is essentially what you're doing is essentially induction. So you are trying to come up with hypotheses about what went wrong and see if these hypotheses, if what you observed follows naturally from these assumptions that you're making. So automating the process of dealing with unknown unknowns is essentially replicating how humans do science. And this requires artificial intelligence, general artificial intelligence, so artificial intelligence that can think like human beings, which is something that we don't have right now. And this is something that we may be decades from, or even hundreds of years from updating.